Morning, this is your Stat Sensei, Mr. Spensei, and this is Chi-Square Goodness of Fit Day 1, and this will be a warm-up. All right, so what you watching is our scenario. Last year, channels 2, 3, 4, and 5 captured the entire television audience with 30%, 25%, 20%, and 25% respectively. What that means is channel 2 had 30%, channel 3 had 25%, channel 4 20%, and 5% and channel 5 had 25%. So to determine whether the distribution changed, advertisers randomly selected 500 viewers. Hey, that sounds pretty important. That sounds like, first off, I love seeing that random selection because you know that's going to tie into a one of our conditions. And it looks like our sample size is 500. So we know, okay, we have N is 500. We also have more than 5 million. So it looks like we have a population here of 5 million. This looks like my pop. And recorded their findings below at a 10% level. So alpha equals 0.10. Um, have viewing preferences changed? Well, what they're going to ask us to do, and I know you can see all the answers here, is in the space, and it should say above and below, list and label the information that you think might be important. Also, how many samples are there and list the variables and levels of each. So let's use the table to help us out. We already said 30% with 2, channel 3 had 25%, channel 4 had 20%, and channel 5 had 25%. Well, we've already done one proportion or 1 and 2 proportion z-test, but here we have multiple proportions. So that's going to be a little bit different than what we had before. Number of viewers, well, this was given to us. I'm just going to let you know this was part of their survey. This was the outcomes. And our sample size was 500. Now, this expected value thing, we're going to show you a neat, clever way to do that when we actually run the test. But right now, what you need to know is expected value is the sample size times the proportion. So if I go 500 times my proportion of 30%, I get 150. 500 times my percent of 25, I get 125. 500 times the proportion of 20, I get 100. And then 500 times 0.25. So that's basically N times P. And you know what, I'm going to make that in blue so it stands out a little bit better against that red. It's the sample size times the proportion for the individual units. All right. So we know that that's important. All right. We know we have a one sample of 500 viewers, so N is 500. Also would say, hey, you know what? We have a population of 5 million. We also know it's a random sample, and we're going to know we need that for our conditions. All right. We also have, hey, they told us our alpha level. So alpha, I'm going to scoot this over here. Alpha equals 0.10 or 10%. And they want to know, have preferences changed? And that's probably important as well, because that's a kind of our question. All right, it says, how many samples are there? Well, what they do? Let's look back at what it says. To determine whether the distribution changed, advertisers randomly selected 500 viewers. That sounds like one sample. All right. And as far as the number of variables, we only have one variable, and that variable is the TV channel. In other words, which one were you watching? And then it asks for, so that's my variable. And then it asks for the levels. Well, in this case, there's 1, 2, 3, 4 TV channels. So the levels would be 4, kind of like back in my day. All right. before cable. So list the variables. We did. We only had one. That's the TV channel, and the levels. There were four, and we marked that. How many samples? We did that, and we identified all the important information, or at least as much as we possibly could. All right. Appreciate you watching, and look forward to seeing you on the next one. Thank you.